Hello. This short video will help you make the most of the formula booklet when doing your AS Maths Statistics paper. We'll look at the formulas given and some related formulas. For probability, there's only one formula given in the AS section, and that's that the probability of not A is 1 minus the probability of A. It's useful to look at the A-level section, which has a bigger list of formulas which can act as a useful aide-memoire during a stressful examination. Let's look at these formulas that relate to probabilities in a Venn diagram. First, the probability of A or B. AUB is PA plus PB minus P A intersect B. You will need to remember the meaning of mutually exclusive. So that's when event A excludes the event B. In this case, the intersection, A intersect B, will be empty. A and B will not overlap. This is the example that I use to help me remember how the formulas work. This Venn diagram represents the students at a college. The set A are those that study art. The set B are those that study biology. The probability that the student studies art will be 17 plus 18 out of 100, 35 out of 100. The probability that they study biology will be 18 plus 37, 55 out of 100. The next formula for conditional probability, in my view, is better rearranged into this form, which shows that the probability of B given A is the probability of A intersect B over the probability of A. Let's refer to our example here. What this is saying is, what's the probability of choosing a biology student at random, given that the student does art? This means we're restricting the set of students from which we draw a random student to those doing art, and we want to find the probability that they do biology. From the diagram, we can see that this probability will be 18 out of the 35. Following this formula, we can see that we have 0.18, the probability of A and B, over 0.35, the probability of A, which is the same as 18 out of 35. The next section will remind you what it means for two events to be statistically independent. Look at the last formula. It's showing you that the probability of A and B will be the probability of A multiplied by the probability of B. If this holds, we say the events are statistically independent. And this relationship can be used to test whether two events are statistically independent. Let's look at the events A and B in the example here. Here, the probability of A and B is 18 out of 100, and that's not equal to the probability of A, 35 out of 100, times the probability of B, 55 out of 100. So we can see that the events A and B in this example are not independent. Returning to the conditional probability formula, in the case of independent events, we can see that the probability of B given A will be the probability of A and B, which is PA times PB, if A and B are independent, divided by PA. We can cancel the PAs, and this gives us the probability PB. So the probability of B given A is the same as the probability of B. So whether or not A is the case has no effect on the probability of B. There are also the formulas for the standard deviation. So sigma is the normal symbol for standard deviation. Sigma squared is the variance. Looking at this formula, we're given SXX equals sigma xi minus x bar squared. X bar is the mean of the set of n values x1 to xn. SXX is the sum of the squares of the differences between the samples and the mean. So this gives some measure of how spread out these values are from the mean, and we average them to give the variance, sigma squared. Two formulas here for calculating the standard deviation. In some questions, you may be given the value of SXX, in which case you can use it directly in this formula. The second formula tends to be the one where you calculate the standard deviation from scratch. In most cases, for raw data, you can calculate the standard deviation on your calculator, but in some questions, they will give you some elements of these formulas to force you to apply them. For data in a frequency table, the formula is sigma fx over sigma f for the mean. Sigma f will equal n, the number of values in the sample. And also we have the formula for calculating the standard deviation from a frequency table. That will be sigma f times x squared over n minus x bar squared. I hope you found that useful, and you'll take a look at other videos in the series. Thank you.